Hey class, in today's lesson we're going to talk about binomial radical expressions, which is found in section 6-3, part 1 of your book. We will add and subtract rational expressions. So on this screen, we have examples of like radicals with like numbers and like radicals with like variables. If you notice in the first set, we have the square root of 2 plus 3 square root of 2 equal to 4 square root of 2. And the reason why we can add those is because their radicand is the same. Just as what's below it, the cubed root of 7 minus 5 cubed root of 7 will give you negative 4 cubed root of 7. Alright, and the same for the other part. The only thing that's different is that those radicands also have the same variables. So in example 1, we're adding and subtracting radicals. So the first one we have 3 square root of 5x minus 2 square root of 5x. Okay, so they obviously have the same radicand, which is square root of 5x. So all we're going to do is take a look at the numbers in front. So 3 minus 2 is 1. So we can either write 1 square root of 5x, or we could just write the square root of 5x as our final answer. Alright, the next one we have 6x squared square root of 7 plus 4x square root of 5. Actually, they do not have like radicands, so this is the simplified form of the expression. And the last one we have 12 cube root of 7xy minus 8 fifth root of 7xy. I'm pretty sure this is probably a typo on my part. This was really supposed to be a 3, so we're going to make that a 3 for cube root. So once again, 12 minus 8 would give you 4. So this is really 4 cube root of 7xy as a final answer. Alright, let's go ahead and try this one. So again, we have 7 fifth root of 5 minus 4 square root of 5. We cannot simplify further because we have a cubed root and we have a square root, so this actually is our simplified answer. The next one we have 3x square root of xy plus 4x square root of xy. Alright, square root of xy and square root of xy are like radicands, so we'll just add the fronts. So 3x plus 4x will give us 7x. So this is 7x square root of xy as our final answer here. And the last one, 17 fifth root of 3x squared minus 15 fifth root of 3x squared. Again, they have the same radicands, so 17 minus 15 will give us 2. So it's 2 fifth root of 3x squared. Alright, example 2. It says, in the stained glass window, the side of each small square is 5 inches. Find the perimeter of the window to the nearest tenth. Alright, so if each side, think about it, if each side of a square is 5, and what we have is the diagonal, remember Pythagorean theorem says a squared plus b squared equals c squared. So really we have 5 squared plus 5 squared equal to c squared, which we don't know. That's 25 and 25. So 25 plus 25 is 50. And to take the square root of that, 50, remember if you break that down, it's 2 and 25, and that's 5 and 5. So really we have 5 square root of 2. And really we should know that from special triangles from geometry, right? This would be n square root of 2. So the diagonal is really 5 square root of 2. So with that being said, let me go ahead and change my pen color. So really, for example, here we have 1, 2, 3 on this side, and we have 1, 2 on that side. And notice the question says to find the perimeter. So we have 3 5 square roots of 2 on one side, plus 2 times 5 square root of 2 on the other side. And then really we have to do that twice. Right? because that would duplicate, that would give us the total around for the perimeter. So this will be 2 times 3 times 5 square root of 2 is really 5 square root of 2 written out 3 times, right? They obviously have the same radicand, so we're really just multiplying 3 and 5. 3 and 5 will give us 15 square root of 2 plus 2 5 square roots of 2 is 10 square root of 2. 15 plus 10 square root of 2 is really 25 square root of 2. And 2 of those would give us 50 square root of 2 as a final answer. So 50 square root of 2 inches is the entire perimeter for the stained glass window. So again, we do the same thing if it's 6. All right, so I can pretty much tell you that that means that those diagonals would be 6 square root of 2. All right, so just like we had in the other one, we're going to have to say 2 times this whole thing. So there were 3 that were 6 square root of 2. And then there were 2 that were 6 square root of 2. So that would give us 2 times 18 square root of 2 plus 12 square root of 2, which is really 2 times 30 square root of 2, which is really 60 square root of 2 inches. And we're done. Alright, so in this problem, now we're going to simplify before adding or subtracting, because here we can see that obviously nothing is in common, alright? So we're going to have to break down each of the radicands to their simplest form and then add or subtract. So 12, we know is 3 and 4 is 2 and 2. So this would be 2 square root of 3, right? Because, and I'll show you, 2, 2, 3. It's square root, so it's pairs. I can take out a 2 and I'm left with a 3. So this one is really 2 square root of 3. All right, 75 is 3 and 25. We know 25 is 5 and 5. If I put that under a radical, that's 5, 5, and 3. So this is really 5 square root of 3. So there's 2 square root of 3 plus 5 square root of 3. And then we have a minus square root of 3 at the end. Now, let's look at the coefficients. That's a 2, a 5, and a 1. So 2 plus 5 is 7. 7 minus 1 is 6. Our final answer is 6 square root of 3. Alright, so try number 3. It says, was the simplest form of the expression. Once again, we still need to get everything down to its most basic form. So 250 is 25 and 10. 10 is 2 and 5, so we're done there. And then 25 is 5 and 5. So because it's cubed root, that's 2 and 3 5s. So this is 5 cubed root of 2. All right, 54 is 2 and 27. 27 is 3 and 9, and 9 is 3 and 3. So it's 2, 3, 3, 3, which is plus 3 cube root of 2. And then finally 16 is 2 and 8, and then 2 and 2, and then 2 and 2. So this would be minus 2 cubed root of 2. So once again, looking at they all have the same ending. They're all cube roots of 2. So that's 5, 3, and 2. So 5 plus 3 is 8. 8 minus 2 is 6. So this is 6 cubed root of 2. And we are done. Alright guys, once again, if you have any questions, please be sure to come see me for tutoring.